Hi class, and this is Mr. Durst here, and in this recording we're going to focus on blood vessels of the trunk, or as your lab objective sheet refers to the blood vessels of the abdomen and thorax. So let's get started at the very beginning with our aortic arch. So here we have our heart. I'm going to go ahead and zoom in on the heart, and we have the aortic arch visible right here. And there's three main branches, 1, 2, 3, coming off of the aortic arch. Our first branch is going to be the Brachio Cephalic artery, and that Brachio Cephalic artery is then going to turn into the right common carotid and the right subclavian artery. Up next, our next branch is going to be the left common carotid, and then finally we have the left subclavian arteries. And as we're looking at those subclavian arteries, I want to highlight the fact that there's a left and right subclavian artery and a left subclavian vein and a right subclavian vein as well. And all of those subclavians are going to be deep or beneath the clavicle. Sub meaning beneath, clavian referring to the clavicle bone. So there's those clavicles, which are right next to the subclavian vein and subclavian arteries. We also have a descending aorta. Our descending aorta is broken up into two segments, the thoracic and abdominal aorta. To find the descending aorta, I'm going to just turn my model around and look at the posterior of our human body. Here we have the aortic arch, and then once it starts going down, and it's posterior to the heart, we refer to it as the thoracic aorta. After the thoracic aorta, we have the descending aorta. The separation point between the descending and thoracic aortas is going to be the diaphragm. So I'm going to go ahead and add the diaphragm for you. Diaphragm, add. So now you can help better visualize that separation between the thoracic aorta and the abdominal aorta. And then if I zoom in really close right here, you can see the abdominal aorta is inferior to the diaphragm. But if I zoom out and flip around my view here, the thoracic aorta is going to be superior to our diaphragm. This is a nice tight view right here. Anywho's, let's get rid of that diaphragm and continue through our list of blood vessels. While we're working with the abdominal aorta, the first major branch point is going to be the iliac trunk artery. And that iliac trunk artery is present right there. So here we have the abdominal aorta. The first major branch you need to know is the iliac trunk artery. And that iliac trunk artery is going to have three blood vessels leading away from it. First, we'll have the splenic vein. Splenic artery. My bad. And that heads to the spleen, which is over here on the left side, upper left quadrant. I'm going to go ahead and add the spleen just so you can see what it looks like. There's the spleen being fed or having blood supply from the splenic artery to the spleen. I'm going to go ahead and hide it now, just so it's not messing up our models. As I continue clockwise around, we're going to then work our way to the common hepatic artery, which leads to the liver. I'm going to go ahead and add the liver for us now. And we can see that common hepatic artery forming a proper hepatic artery, which then goes to the left-right branch that then supplies our liver. And I don't have the entire liver shown right now, but I have a good chunk of it. And let's back up, liver, and hide. There we go. And then finally, the last branch coming off of our iliac trunk is going to head superiorly, and that is the left gastric artery. Let me go ahead and add the stomach. And as we look at that left gastric artery, you can see how it supplies blood to the stomach right there. So let's go back to our iliac trunk, our abdominal aorta. Oh, by the way, just in case I forget to mention this, I want to highlight that the inferior vena cava is the major vein that goes all the way through the trunk of the human body. Back to the abdominal aorta, though. So as we're heading down our abdominal aorta, our next major branch coming off of the abdominal aorta's actually been cut off right there. Our next major branch is going to be the superior mesenteric artery. I'm going to go ahead and add that to visible body right now, or VB model for you right now. Apparently, visible body is having a bit of a brain hiccup right now. Sorry about that, class. But directly inferior to the iliac trunk, we have the superior mesenteric artery that I'm circling right now with my mouse, but has been cut off from my model, and due to some technical issues, isn't showing up right now within visible body. Up next on our list, class, we're going to cover the gonadal arteries. And as we look at the gonadal arteries within the human body, the gonadal arteries, a male, are going to be symmetrical with each other. So we have a left and right gonadal artery that are going to have symmetrical entry points or exit points from the abdominal aorta. But as we look at the gonadal veins, they are asymmetrical. They do not have symmetrical exit points or entry points into the inferior vena cava. As we're going to continue our trip through here, we're going to then move on to the inferior mesenteric artery. The inferior mesenteric artery is this blood vessel right here, this major branch coming off of the abdominal aorta. And then from there we have a common iliac artery that branches to the external iliac artery and internal iliac arteries. So as we're looking at the common iliac artery, we have one there, we have one there, and then they branch to external iliac arteries and internal iliac arteries. And to highlight the other side, we have the internal there and the external there. And those are the major arteries, class, of the abdomen and thorax. Let's move on to our major veins. So as we look at this list right here, we're going to start from the inferior and move our way superiorly. So as we're going to look at this, I need to add a couple blood vessels here. Vena cava. There we go. So we'll start with our external iliac vein and internal. Oh, excuse me. Let's go ahead and hide that one. Our internal iliac vein, and we have identical ones on the left and right. And then they merge to form the common iliac veins, which then are going to merge to form the inferior vena cava. And as we're heading superiorly with the inferior vena cava, we have a lot of other major blood vessels that we're going to cover. So next, let's cover the common iliac vein. As we're looking at that common iliac vein, the common iliac vein is going to be located right there, as I had mentioned, and then that merges to form the inferior vena cava, or cava, depending on if you're whether you're from the East Coast or the West Coast. Up next, we have the gonadal veins. And the gonadal veins get to be a little bit tricky. There are some asymmetries. between the left and right gonadal veins. So let's highlight those for you right now. The left gonadal vein is right here, and that left gonadal vein is going to come from or drain into, I should say, the left renal vein. The right gonadal vein, though, is going to drain immediately into the inferior vena cava. So what we typically find here is that there's better drainage for the right gonad, the right ovary and the right testicle, compared to the left ovary and left testicle, whether we're looking with a biological male or biological female. Interestingly enough, just as an aside, what we typically find, particularly in males, is that if there's going to be some kind of a swelling or varicosity developing in a testicle, overwhelmingly it's going to develop within the left testicle, because the left testicle has poor or less pronounced drainage compared to the right testicle. And the key reason for that all has to do with just simple fluid mechanics. The right gonadal vein drains directly into the inferior vena cava, so it's an easier drain, easier access point, whereas the left gonadal vein drains into a smaller blood vessel, so it's not as efficient at pulling blood away from the gonad. We have our renal veins, we have our left renal vein and right renal vein as we're heading superiorly up the vena cava. Up next, we have our hepatic vein. The hepatic vein is going to drain directly into drain blood directly from our liver. So here we can see that, not the hepatic portal vein. There we go, our hepatic vein. These hepatic veins in visible body are broken up into separate ones. Ms. Laundrich and I do not expect you as students to know or differentiate between the three main branches of the hepatic vein. Just know that the hepatic veins are these main veins that drain directly from the liver. I'll go ahead and add the liver again for a frame of reference. So we can see the liver right here, and then we have the hepatic veins coming directly from the liver. And I didn't add all of the liver. So we have our left hepatic vein, intermediate, and right hepatic vein. Just the hepatic veins in general. And let's go ahead and get rid of the liver, at least the left part of the liver. There we go. Let's move on and talk about the azygos vein. The azygos vein is pretty cool. It's going to back us up here. For some reason, my model just keeps having these major blood vessels disappear, which is rather frustrating for me. So I'm going to back us up a bit and go to this view. And yep, they keep disappearing on me. Let me go ahead and add our superior vena cava. And it looks like my inferior vena cava has also been misplaced. I lost my inferior vena cava, oh my! But there we go, it's back again. So as we're looking at these veins that are carrying blood towards the heart, we're going to have a Zygos vein. There we go. Leading to the superior vena cava, we have this azygos vein. And usually, most of the time we view the azygos vein, it's going to be on the heart model. But since we have visible body and we're working with it this semester, let's talk about the azygos vein as a whole. It's going to drain directly into the superior vena cava. But as we look at it here, it is going to follow our vertebral column throughout most of the thoracic or throughout most of the trunk, and then will form the lumbar vein. So our lumbar vein is going to merge with other veins to form the azygos vein, which then drains directly into the superior vena cava. And then let's look at our brachiocephalic veins, which of course have disappeared too. Apparently, I just have problems with blood vessels disappearing. BRA brachiocephalic, add. Let's add the other one too. There we go. So as we're looking at our superior vena cava right here, we have two brachiocephalic veins, one on the left, one on the right, that drain into the superior vena cava. And that's it for major blood vessels of the abdomen and thorax. If you have any questions or comments, please feel free to post them in the class discussion board. And as always, happy studies.